With the upcoming Maryland Tech Invitational robotics competition, FTC 18253 BeachBots introduces its second iteration robot with a specific designation for in-person competition. Though the competition is about robots, the process also matters. Going through iterations, testing, struggling to succeed, and working those long nights. This is what represents our team. We'll be going through a high-level overview of specific processes used, including what failed and what worked, and also covering considerations of simplicity and reliability that we as a team emphasize. When starting on our second version of the BeachBots Ultimate Goal robot, we researched and brainstormed robot designs before settling on our goals for the competition. This includes watching in-person matches from early competitions, such as Utah. Research also includes our personal experience gained from the season, such as the struggles of an in-person robot in 54 hours at Utah Park State qualifiers, or the previous knowledge gained from iteration 1 of the robot using official competition. With the information in mind, our team was confident that we could set our goals and constraints for the robot. Goals for this robot include a 6-wheel drivetrain, centered wobble goal, a surgical tubing intake, a curved shooter, and approximately 18-inch release height from the robot to prevent defense. Goals such as these were meant to be specific, but with the actual implementation of each task vague. Organization is a key feature, and the utilization of an online calendar helps us meet the goals set for the robot. Designing the robot to be accurate when building requires the use of computer-aided design software, specifically Onshape. When designing, we considered factors such as how easy is the robot to take apart when maintenance is ultimately needed? Would this part be strong enough to withstand the rigors of competition? Is this the simplest design possible? Part of the robot, such as the intake belts and electronics, contain polycarbonate shielding to prevent ramming, and testing the specific mechanisms beforehand to ensure the robot will not break mechanically at the competition. Currently, a 4-motor 6-wheel drivetrain, 2-motor intake, 2-motor shooter, and 3-servo wobble goal allow our robot to quickly suck and outtake the rings and manipulate the wobble goal.
A 6-wheel drivetrain was designed for defense with 72mm wheels and outer omni wheels. A custom traction wheel was used, with anti-mark tread to prevent defense on our bot from an in-person setting. Setting our goals with a 6-wheel drive allows us to utilize the increase in acceleration and deceleration, along with more traction against mechanism drivetrains to play defense very effectively. Intaking is one of the most critical parts of this game, and our intake uses a combination of long and short surgical tubing to achieve fully vertical and fully flat rings intaking. The tubes push the rings into the start of the robot, where a bottom roller geared in the opposite direction pushes the rings onto a ramp, and for the transfer stages to fully push the rings into our hopper. A beam bounce wheel along with 2 geared 1-to-1 motors allow for our shooter to shoot all 3 shots in under a second, and a curve that flies straight. This is due to various testing and earlier iterations to achieve the results now. Our wobble goal mechanism is made to be as strong as possible, utilizing go-tube axles to increase the simplicity and strength of the design.
Consistency and reliability define our robot, and as a result, defines the team that we are. We thank you for your time and hope to see you at the competition field.